I hope you watched the previous video and you have learned what are the steps involved in plotting the Nyquist criteria or Nyquist plot for commenting stability of a control system. Now let us solve the problem by using those steps which you saw in the previous video. So in the first problem, if you see here, the g of s and into h of s is given by 10 divided by s plus 1 into s plus 2. So what you need to do in first step here is we need to identify is there any pole at the origin. So we don't have any single s term here in the denominator. So therefore we don't have any pole at the origin. So we need to write the first counter diagram, initial foundation diagram. So I'm going to write the counter diagram which we are going to use for this particular problem. So you will not be getting any semicircle here, means a small semicircle here. So you will be having an outline like this, and then you will have a semicircle in this way. Okay, and then let me write r tends to infinity. So I'll have plus j infinity, where omega is infinity, here minus j infinity, omega is minus infinity, angle is minus 90 degree, and angle is plus 90 degree here, and here angle is 0 degree and 360 degree. Okay, and this is angle theta, and here the angle is minus 180 and plus 180, and we know this is real value towards minus infinity, and if you go this side, it is real value towards plus infinity. So this is the basic contour diagram. First, we need to write for this particular problem or for this question, because there is no pole at the origin. So this becomes A, B, and then C, and then D. Okay, so A, B, C, D. So now the second step is we need to write the pole zero diagram and identify what are the number of poles towards right half of S plane. So for that, we need to write the pole zero diagram. Okay, so the poles what we have here is that one pole is at -1, one pole is at -2. So -2 and -1. So we don't have any pole towards right half of this plane. Therefore, the value of P, the value of capital P is equal to 0. The value of capital P is equal to 0. So this is the value of P which you just identified. So this says that for this particular given transfer function of any of the control system, open loop system is stable. Means if this transfer function is generated when the system is open loop, then the open loop is actually stable because P equals 0. Now, let me go to the next step. The second step is, the next step is we need to draw the conformal mapping. We need to draw the conformal mapping, or we need to draw the contour. So in this problem, the contour is A, B, C, D, and A. Okay. In this problem, it is A, B, C, D, A. So when I want to draw the contour A, B, C, D, A, it goes with three different sections. The first section one is path A, B. If you see here, if I want to draw the contour according to the Nyquist criteria, the first path is A and B. The second path is, that is second section, section 2, path C, B, C, D is completely considered as next section because it's complete, it's a semicircle. Okay, you cannot take BC separate and CD separate. That complete semicircle is varying in terms of R tending towards infinity. So therefore, the second path will always be B, C, and D. And finally, the third one, or the third path, which is section 3, is the path D. Okay, so AB, path BCD, and path D. Okay, so now let me take first section 1. So let me take section 1 and try to draw the contour for section 1, which is path AB. Now for doing this, let me consider the given problem which was given as g of s into h of s equals 10 divided by s plus 1 into s plus 2. So when I'm drawing path AB, this is the step which I told you that I'll be discussing while solving the problem. First, you need to take J of S into H of S, whatever it is given. Now, try to substitute S as J omega. So for this, you get G of J omega into H of J omega equals 10 divided by J omega plus 1 into J omega plus 2. Now, what we need to do here is we need to do two different things. We need to write this entire expression in terms of magnitude and phase. Okay, so magnitude and phase. If I do that, the magnitude of 10 into phase of 10 divided by magnitude of j omega plus 1 into phase of j omega plus 1. Similarly, magnitude of j omega plus 2 into phase of j omega plus 2. So this is what we do in Nyquist criteria. So we need to take magnitude and phase for each parameters. So if I go with this, magnitude of 10 will remain to be 10, whereas angle of 10 value, I hope I told you in the Nyquist plot and all, when we have a complex number a plus jb, the magnitude will always go with root of a square plus b square, whereas angle will always go with the tan inverse of b by a. So this is a general formula which we have for magnitude. So this goes with for magnitude, this goes with for phase. So if our magnitude of 10 is 10, but whereas angle for 10 will be equal to 0 degree. Because a is 10, but b is 0. Root of 10 square plus 0 square is root of 10 square, so it remains to be 10. Divided by magnitude of j omega plus 1 is root of omega square plus 1 square, which is 1. Angle is tan inverse of omega by 1 is omega into magnitude of j omega plus 2 is root of omega square plus 2 square is 4 into tan inverse of omega by 2. Omega by 2. Now what I'll do, I'll keep all the magnitude separate and angle separate. So what will I get here is, I'll take 10 here divided by root of omega square plus 1 into root of omega square plus 4, and I'll write only angle terms here, which is angle 0 degree divided by tan inverse of omega into tan inverse of omega by 2. Okay, so this is what the formula we got. Now, as we are tracing the path AB at A, you are able to see at A, point A, if you go back to the contour diagram, see, at this point, if you see, at B, omega is infinity, but at A, the omega value is 0. Omega value is 0, and angle is also 0. Okay, so anyway, at A, omega equals 0, at B, omega equals infinity, at A, omega equals 0. So therefore, the magnitude will be equal to 10 divided by 0 plus 1, 0 square plus 1 is 1, 0 square plus 4 is root 4, which is 2, into 0 degree divided by tan inverse of 0 into tan inverse of 0. Anyway, this will give me a magnitude of 5 at an angle 0 degree by 0 degree and 0 degree. So therefore, the angle is 0 degree. So this is at point A. Similarly, at point B, we see that omega equals infinity. Therefore, the magnitude term so magnitude and angle is separate. Okay. So the magnitude term for omega equals infinity becomes 10 divided by infinity. The reason why 10 divided by infinity, because if you substitute omega equals infinity here, root of infinity is again infinity. This root of infinity square is again infinity. Infinity into infinity is infinity. 10 divided by infinity is what you get. And the angle is 0 degree divided by tan inverse of infinity into tan inverse of infinity divided by 2 is infinity. So this will give me the magnitude. This will give me the magnitude. Anything divided by infinity is 0 at an angle. See, this is 0 degree. This is 0 degree. Because tan inverse of infinity is 190. Tan inverse of another infinity is another 90. This 90 plus 90 becomes 180. And in the denominator, if it is 180, and if I take to the numerator 180, it becomes minus 180. So therefore, the magnitude is 0. The angle is minus 180. Minus 180. So therefore, if I draw the trace for path AB, so this is the path Okay. Now at A you see that magnitude is phi and angle is 0. So angle is, this is angle 0 degree. Okay. This is angle 0 degree. And let me take somewhere here it is magnitude, real value. See, this magnitude should be on real axis and it is 0 degree means the magnitude value comes towards this side and assume this is phi. So from here to here it is phi and the angle is 0 degree. Whereas for this point what we say it is A, but I'll take this as A dash so that ABCD label is given in the contour diagram, foundation diagram. So I'll take this as new value of A, which is A dash. Okay. Similarly, the contour for B, which I will consider as B dash. Now why B comes here? Because the magnitude is 0. So when magnitude is 0 or angle is 0 degree, you will be able to get it on origin. Okay, magnitude is 0 means it is at the origin. And from A dash to B dash, you need to go from A dash to B dash. That is what we are able to do here. You see that some contour diagram, you are going to trace a path from A to B. Okay. So therefore, the new contour in this problem, what we can see here is at A it is 0 degree, and when A, the transfer function when it is traversing to B, it goes with minus 180 degree. And we know that minus 180 degree is this line. So what happens here is my contour from A dash to B dash will be in this direction, like this. So this is B dash. So from A dash starts from 0 degree at phi magnitude, it goes to the magnitude 0 at an angle minus 180 because you got 0 at an angle minus 180. So A dash meets B dash at an angle minus 180 degree from 0 degree. So this is the trace or the path A dash B dash. Okay. We had an initial foundation counter is this A to B, but for this particular problem which we have given, which we have taken, the path becomes this. Now let me go to trace. Let me go to the next trace. So let me go to section 2, which is path BCD. Path BCD. Now the path BCD is very important. Here, if you go back to the counter and check what is path BCD, path BCD is the semicircle with r tending towards infinity. So what we consider here is we try to take S equals r into e power j theta, r into e power j theta, r into e power j theta. We assume S equals r into e power j theta where r is tending towards infinity. So therefore, what we do for BCD here is for any problem you take, for the section 2 path BCD, we will try to take R, we will try to take S replaced with R into e power j theta, where R is tending towards infinity. So this can be written as, put S equals limit R tends to infinity, R into e power j theta in the given question, in the given transfer function. So if we do this, our transfer function becomes g of r into e power j theta h of r into e power j theta equals 10 divided by, we have s plus 1, so therefore it becomes r into e power j theta plus 1, r into e power j theta plus 2, whereas the limit should be considered here, so I'll take limit. So what I do is I'll push this entire thing towards a little bit this side, and I'm try to write limit r tends to infinity. Now in this equation, if you see properly, the limit can be applied only for the r term, right? Therefore, I can easily write this as 10 divided by limit r tends to infinity r into e power j theta plus 1. So plus 1 will go off. So what I do is plus 1 will go off because no limit can be applied to plus 1. So that is not required, into limit r tends to infinity. Again here plus 2 will go off because there r term is not there. So r will only be with this. So I can easily say that it is 10 divided by limit r tends to infinity r square into e power j 2 theta, because e power j theta into e power j theta is e power. So we know that e power a into e power b is always equal to e power a plus b. So that is what I've done here. E power j theta and e power j theta plus j theta becomes j2 theta. So this can be further written as 10 divided by limit r tends to infinity r square, whereas e power j2 theta, if it goes to the numerator, it becomes e power minus j2 theta. Okay, so this becomes, when I substitute r as infinite, the magnitude term 10 divided by infinite square becomes 0 at an angle e power minus j2 theta. Now, as we all know that we are trying to trace the path B, C and D. Now, if you look into the angle at B, the angle at B is 90 degrees. If you see here, if you go back and see the contours diagram, the angle at B is 90 degree, angle at C is 0 degree, and angle at D is minus 90 degree. Therefore, angle at B is 90 degree, this is 0 degree, and D is minus 90 degree. If I substitute that, this term will become 0 at an angle when e power minus j2 theta, when theta is 90 degree, the angle becomes minus 180 degree. Why? Because 2 into 90 is 180 and negative is there. So minus 180. When theta equals 0, angle is 0 degree. When theta equals minus 90, it is minus of 2 into minus 90, which is plus 180 degree. It means that 0 at an angle minus 180 degree is the magnitude at phase at B. 0 at 0 degree is at C. 0 at an angle 180 degree is at D. Okay, is at D. But if I want to plot the trace diagram for this BCD, so I'll just plot the trace diagram for BCD. Carefully see this. The B value is magnitude is 0. Magnitude is 0 means at the origin. Okay, magnitude is 0 means at the origin. Angle is minus 180 degree, which is this minus 180. Whereas C value, so this becomes B dash point. So I'll just write as B dash because this is a new trace. Whereas C, the magnitude is 0, angle is also 0. So magnitude is 0, angle is 0 degree. Therefore, this point will also become C dash. Same point. Now when you go with the D, magnitude is 0. So therefore, magnitude is 0 means the same point. Whereas angle is plus 180 degree, so it becomes this one. So therefore, this same point is also D dash. So this is the path. This is the path BCD. BCD. Okay. So section 2 path. This is the new path. You can see at the origin you have all 3 points BCD, whereas in the initial counter it was a semicircle. It was a semicircle in the initial foundation Nyquist criteria counter, but in this particular problem, for this particular problem, we were able to see that B dash, C dash, D dash is at the origin with an angle 0 degree, minus 180 degree, plus 180 degree angle. Now we'll go with the next section, section 3, which is path DA. So in path DA, it's very simple. If you see the counter diagram, if you see the Nyquist counter foundation diagram, the path DA will definitely be the mirror image of AB. Keep that in mind. Path DA is this side, AB is upper side. So whatever you want DA path, that will be same equal to AB, but that becomes a mirror image of AB. So we have got, this is AB. I'll just write the trace of DA here itself so that you will be able to see it properly. Okay. Okay. Now I need to draw DA. So DA. So now A is 0 degree. Now phi becomes minus. The phi remains to be phi. Okay. Phi remains to be phi here. Okay. A dash point is phi. So from here to here, whatever we say, it is phi. Now the contour of A dash B dash is in this way. So the contour of A dash and D dash will become this direction. So it is a mirror image of A dash B dash. Okay, it is a mirror image of A dash and B dash. So it is the mirror image of A dash and B dash. So this is your B dash. sorry, D dash is the mirror image of A dash and B dash. So this is A dash and D dash. Now the D dash is what mirror image means. It will be at plus 180 degree. See, 180 degree minus 180 degree, and it is now moving towards. This was moving from A dash to B dash. So this point A dash to B dash. Now this is what you see is moving from A dash to D dash. Okay, so A dash to D dash to A dash. Sorry, we are going from D dash to A dash. D dash to A dash. So what we do normally is we will traverse from A dash to B dash is section 1, B, C, D is section 2, and D to A is section 3. So D to A is section 3, so the arrow will go in this direction, whereas A to B is section 1, so the arrow will be written in this direction. Now what we do is we will try to join all these 3 different traces and write a single diagram here. I'll try to write a single diagram. This is the final Nyquist contour for this particular problem. So I do have phi somewhere here. Phi somewhere here. Okay, when the distance between origin and A, the magnitude for A is actually phi. Okay, now the curve, this is point A dash. This is the point which we saw in the earlier trace. It is B dash, C dash, D dash. Now we have one path of the curve which goes like this and meets the origin, and another path of the curve which is a mirror image of A dash B dash, which is D dash to A dash. So D dash to A dash. I've written roughly. Now the arrow is A dash to B dash, D dash to A dash. So this is the diagram. So this is 0 degree, minus 90 degree. This is plus 180 and minus 180. This is omega equals infinite. Here omega equals minus infinity, and here omega equals 0. Okay, so this is the final trace which we obtain when we attach all 3 traces. And if you try to see in explain, always minus 1 plus 0j, minus 1 plus 0j. This is the encirclement which we are trying to see now. So we need to see whether this trace what you have drawn is encircled the point minus 1 plus 0j. Okay, the trace what you have drawn here, whether it is encircled with minus 1 plus 0j. That is very important. So an encirclement of minus 1 plus 0j will give you the value of capital N now. Now where is minus 1 plus 0j? 0j means there is no imaginary value. Minus 1 means it is left half of a straight. So somewhere after this 0 point is actually minus 1 plus 0j, this one. So this is the point minus 1 plus 0j. And if you see this curve, whatever it is drawn, this curve is not at all encircling the minus 1 plus 0j. Okay, minus 1 plus 0j encirclement means it should encircle this particular point. Our trace for this particular problem, it is not at all encircling minus 1 plus 0j. Therefore, the value of capital N equals 0. There is no encirclement at all. So for the same considered problem, we saw in the beginning that P was equal to 0. See, go back and see. In the previous first step when we did, P was equal to 0. And for the same problem, we also have N equals 0. Therefore, finally, the calculation, the last step which I told you in the previous video, we are going to calculate Z, which is P plus N. So here P is 0, N is 0. Therefore, Z is 0. So therefore, this particular transfer function makes sure that even the closed loop control system is also stable. So in this problem, we also got stability for both open loop and closed loop. Even open loop was stable, and even the closed loop is also stable. So this is the Nyquist criterion steps and methods. I hope you understood this problem. Let us look into a new type of problem in our next video. Thank you.